Hey everyone, so now we're going to be talking about function operations. So we've talked about what a function is, we've talked about key features of functions and the domain and ranges of functions. Now we can kind of mess around with them and do some stuff with functions. So um, functions are usually set up in what's called function notation, and function notation, instead of writing y equals, you write f of x equals or g of x equals. Um, and that just tells you that it's a function. You would say that f is a function of x, meaning that when I plug an x into something, I get some f of x out of it. This is really just a notation thing. It's not crazy important, but you do want to understand that when you see an f of x equals or a g of x equals, that it is considered a function. So there's a couple of different things that we can do with these functions, and they're all pretty simple, but for all of these examples, I'm going to be using the same fx and gx. So I'm going to write them down. We've got fx equals 4x plus 5, and then gx equals x squared minus 1. So like if we were to graph these or put them into a table or things like that, we could determine that they are functions. I'm just going to tell you right off the bat that they are functions, so you don't need to double check them. So the first example on this function operations is f plus g of x. And what that tells me is that I'm going to take, another way to write that really is f of x plus g of x. Okay? So what we're going to do is we're just going to take our fx equation and add it to our gx equation. So I'm going to write my fx equation, which is 4x plus 5, then add it to my gx equation, which is x squared minus 1. Now, because it's adding doesn't change any of the values or change any of the signs. So all we have to do is combine like terms. So we've got a 5 right here that doesn't have an x, a negative 1 that doesn't have an x right here. So we can actually just add those together. 5 minus 1 gives me 4. Then the other guys, the x squared and the 4x, they don't have like terms, so we just rewrite them. We're going to say x squared plus 4x and then plus 4. This is my final answer. Notice that I put the x squared first and then the 4x and then the 4. That's what's called standard form. Standard form is when you have the highest exponent first and then it drops exponents as you go until you have the lowest exponent last. All of your answers should be in standard form just because it's prettier, but it doesn't necessarily matter too much. Okay, let's go through another example. So this next example is 3g minus 2f of x. And once again, we're going to just kind of rewrite that so you can see it a little bit better. It'll be 3 times g of x minus 2 times f of x. So really, this first way is just a fancy way of writing it, but notice that you just attach an x to the end of each one, and it's fine. So we're going to do 3 times g of x, which would give me 3 times, and then your g of x is x squared minus 1, minus 2 times your f of x, and your f of x is 4x plus 5. Now in this case, what we're going to do is distribute inside the parentheses, and then we can combine like terms. So when we distribute the 3, we get 3 times x squared, which is 3x squared, and then 3 times negative 1, which gives me a negative 3. Now when we distribute the 2, we're going to actually distribute a negative 2. So because that negative sign, so we're going to do negative 2 times 4x, which gives me a negative 8x. Then negative 2 times 5, which gives me a negative 10. Now I can take those numbers and combine like terms. So we've got a negative 3 and a negative 10. And that gives me a negative 13. Then the other guys, the 3x squared and the negative 8x, those don't have like terms, so we just rewrite them. And this is my final answer, 3x squared minus 8x plus 13. All right, let's go through another example. And this one is going to be f over g of x, or f over g times x, which is just a fancy way of writing f of x divided by g of x. Okay, and then I'm going to come and take these guys so we can see them a little bit better and move them down here. Okay, so when I do this, I'm just going to put the fx on top, which is 4x plus 5, and then the gx on bottom, which is x squared minus 1. And the division, while it looks a little bit more complicated, it's actually pretty easy because this is actually just our final answer. There's nothing that we can do to simplify it, so we just leave it as a fraction in that form. Okay, and then one more example. And this example is g times f of x. Another way to write this is g of x times f of x. So we just write g of x equation, which is x squared minus 1, then times your f of x equation, which is 4x plus 5. When you multiply these things are called binomials. So when you multiply them, you have to FOIL. FOILing means that we're going to multiply FOIL, if you remember, stands for first, outside, inside, and last. So we're going to multiply the first chunks together. X squared times 4x would give me 4x to the third power. Because when we multiply x's, you add the exponents, and this little x has like an exponent of 1. We never put the 1 there because it's kind of just this imaginary thing that we assume, but it's there. And then we're going to do the outside ones, which are the x squared and the 5. So 5 times x squared would give me a 5x squared. Then we're going to do negative 1 times 4x because those are your inside numbers, which would give me a negative 4x. Then your last numbers, so negative 1 times 5, which gives me a negative 5. Then potentially we could combine like terms. In this case, there are no like terms, so your final answer is right here, 4x cubed plus 5x squared minus 4x minus 5. And there we have it, function operation.